Okay, so today we're going to look at the cosine rule, and it's a different rule to the sine rule. Even though the word sine appears, it's a different rule. So again, I'm going to show you the proof because it's important that you know that these things don't get made up. And I've been talking with Dr. Tenniswood, so we're in 2016. For future people, Dr. Tenniswood is another teacher here. Okay, so we're going to let you have access to the formulas for the test, so you don't need to memorize them. But anyway, I'm going to prove it to you how the formula works. So rather than in the sine rule, I'm looking at like Pythagorean relationships. So this triangle here, this first triangle here, a squared, okay, there's your right angle there. So a squared equals h squared plus b minus x. Now what I've done, this along the bottom is b, and I've broken up into x length, and the other length is b minus x. So those two numbers, x and b minus x, add up to b. So I've still got my b, but I've broken up into two sides so that I get two Pythagorean relationships. So there's a little bit of maths. So hypotenuse squared a squared equals h squared plus b minus x. Now b minus x squared, I know that you don't like your expansions off the top of your head, but b minus x squared equals b squared minus 2bx plus x squared. That's just the perfect square. And then taking into account the minus sign out the front, the b squared turns into a minus, the minus turns into a plus, and the plus turns into a minus. And so that's what h squared equals. So that's the first one. And then on the other side, I got a really neat triangle again. So this time c is on the hypotenuse. So c squared equals h squared plus x squared. And then take the x squared across by subtracting. So h squared equals c squared minus x squared. Okay, so I've jumped up too high. Now, that h squared and that h squared and that h squared are the same thing. It's the same height. So that means that this number here, okay, that expression there must be the same as that expression there. So those two things are the same because they're both equal to h squared. Now just rearranging stuff, I want to make a the subject. So then the minus b squared becomes a plus b squared. C squared is still c squared, it hasn't moved. Plus 2bx becomes minus 2bx. And this minus x squared and this minus x squared just cancel out because they're the same number. You're just subtracting x squared from both sides, so they cancel out. Now, this x is what we're trying to get rid of. So over here, okay, I've got this angle, this point is A, so that's the angle A. So cos A equals the adjacent side, which is x, that's the adjacent side, over the hypotenuse. Cos is adjacent over hypotenuse, okay? And then making x the subject, get rid of the divide c, that cross multiplies. So I've got c cos A, and then that x comes over and it turns into that x. So I've got x equals c cos A. So in the end, I get this really neat formula. A squared equals b squared plus c squared minus, stop changing thing, minus 2bc cos A. Or, jumping up again, if instead of having a squared as a subject, I want cos A as a subject, okay, so all of this comes across to start with and becomes a positive, and then that goes backwards and becomes a minus, so I get b squared plus c squared minus a squared, and then this minus 2bc, when it comes across to this side, becomes a plus 2bc, and then to get rid of 2bc, I divide by 2bc. So playing around a bit, but anyway. So I've got two formulas which I'm going to write on the next page. So I've got a formula with the length squared out, length out the front, and the other one is with an angle out the front. So don't need to copy that down because on the next page I've just summarised them. So we've got a squared equals b squared plus c squared minus 2bc cos A. So it's a pattern. If A is the subject, you've got B, C, and you've got BC again, and then A matches A. So if you've got A squared out the front, you've got cos A at the back. And you use this when you're looking for a side and you've only got one angle. So there's no two angles anymore, which was the sine rule. Okay, when we had the sine rule, you know, we had A over sine A equals B over sine B. That was the sine rule. And you needed to have two angles. Now you've only got one angle, so you can't use the sine rule. Or, if you want to have this variation of the form, when you are looking for an angle and you've got three sides. Okay, so again, it's a pattern. If you've got a at the front, then a is at the back. And it's b squared plus c squared minus a squared. And then those two letters, b and c, are what we divide by. So again, you're going to have access to these formulas, so you don't have to memorize them like we used to have to do. And we'll look at 2 examples. So copy them down and come across. Okay, so there's an angle, there's a side. So that's my, what was A, and that's my capital A, okay? You can't use the sine rule because you don't have 2 angles. You don't have, if you're going to use the sine rule, you would need an angle there, opposite 6.1, or you would need an angle there, opposite 5.7. They don't exist, so you cannot use the sine rule. And in this particular question, I want to find x to 2 decimal places. So x is a, so a squared equals b squared plus c squared minus 2bc. So whatever these numbers are here, they're the numbers that go there. And then you go cos 47, because this is a and this is capital A, so that's cos of 47. And then you get this number 22 point blah blah blah. It's a big number, and then you've got to remember to square root at the end, because you can't have a triangle with 6 and 5 and 22 as the other side. They don't make a triangle. So most common mistake is you forget the square root, but you won't, because I'm telling you, square root. So the answer is 4.72. So the triangle is 6.1, 5.7, 4.72. Okay, so copy that down when you're ready. Come across to the next slide. Okay, so we're doing the other one, finding theta to the nearest minute. So you've got 3 sides, that, and that. And again, you can't use the sine rule because you need another angle or something. You need an angle here opposite 6.1, or you need an angle here opposite 9.1. So here, you have to use the cosine rule. Okay, so we say this is A, and this is capital A. Okay, side opposite is the relationship. So cos theta, which is like cos A, equals b squared plus c squared minus a squared. So these 2 sides are your a's. So if that's a, then the side opposite is at the back, and then you divide by 2bc, which are these 2 numbers here. Now, it's just as easy, I think, just to do your decimal approximation to 4 or 5 decimal places, and then just go shift cos that number. So whatever that number is, go shift cos, and then the answer is 3723. Now don't forget, this answer, if you stuff it up, you've got to remember that cos has to be between 1 and minus 1. So if you get an answer here bigger than 1, you've made a mistake somewhere, because you know cos theta can't go bigger than 1 because of the unit circle. So if you make a mistake, find it, get your answer back to less than 1, not less than 0, less than 1, and then you can go shift cos. Now if by some fluke you ever get an angle like 0 degrees, 26 minutes, obviously you could have an angle with 0 degrees, but you've made a mistake. Your answer has to be sensible, something with some sort of number. Okay, so that's the end of the cosine rule, and there will be obviously some practice questions that we'll load onto Moodle. Thanks for that.